Welcome everyone. So thanks for joining me on this video where I'll be explaining various ways that you can use to create surfaces in BitByBit. And you can find the example here under the NURBS section, and just by clicking this example you will open the script that will look similar to this one. It's not a very complicated script, but it sort of tries to show all the ways that you can use to create the NURBS surfaces. If you're not familiar with the NURBS, just Google that out. It's NURB. That stands for non-uniform rational B-splines. It's quite a heavy mathematical term, but basically it's just sort of a lightweight method to create the geometry in various CAD applications. That's used in Rhino as well, in SolidWorks, similar modeling techniques. BitByBit is very lightweight. It's not competing with professional modeling software, but it's definitely usable and interesting, and can provide a lot of nice scenarios for your parametric models. So if we dive in, the script is sort of sectioned into 6 parts, and every part is responsible for a different surface. And you see that at the if you look at the script, each part is like draw surface, draw surface, draw surface. And if you want to know which one is doing what, just click that and you see that the surface lights up that is responsible for so you know how to link the script with the model itself. Let's see if I do that. You see that this is how it all works. So let's just go one by one through those surfaces and see how they are made. The first one is of course the most simple one. It's the sphere itself. So the sphere only needs the center point and the radius. The bigger the radius, the bigger the sphere. So if I make this to 2, you will see that sphere just blows up, and it's getting bigger. If you want to change the color, you can do that. You can also move the sphere center upwards. So then you will see that it sort of goes up. And that's it. Sphere is very basic. It's nothing, it's not complicated at all. And let's then just go to another example. And that's the cone. Cone is also not very complicated, but you see if you compare it to the sphere, it has quite a few more inputs. So for the cone you will need the axis, you will need the x-axis, the base, where the center is. So it's sort of, if I put that to 2, you will also see our cone move up by 2. The height of the cone just regulates the height. So if I make it to a lower value, you will see the cone becoming smaller. And if I make it to 4 or 5, you will see it getting bigger. It's quite standard, quite simple, but still you can play around. You see that radius is the radius of the base, and if you make it bigger, then it will become it will have the same radius as the sphere. So this is how you construct the cone, and we only do this transformation of movement so that it doesn't overlap with the sphere. If this transformation wouldn't be made, or it would be on 0, 0, 0, so then it would just go inside the sphere. But you see that this is also a way that you could potentially model something nice, like a clown with a hat. I'm joking, but yeah, like why not? Let's make it red for fun. Yes. So now it's now it's a sort of face with a hat on it. Next thing in the list is the cylinder, and the cylinder is very similar to the cone. cylinder is just having the radius as well, and it will not go to one point, but it will, you see this, the cylinder is this orange geometry that we have here. And so if you make the radius bigger, of course you will see the cylinder getting bigger and larger. The height of the cylinder is also exactly what you would imagine it to be. And you can orient, of course, the cylinder in many ways, and it's also transformed by the movement of XYZ vector, and it just moves to -2 to also not overlap with the sphere. If we put it on 0, it goes here. We can begin making some model here. I have a feeling it's possible. Let's make it a bit higher. 1.5. Yes. So that's that's beginning to look like some sort of character. Very primitive, of course. But you get the idea, I guess. These three surfaces are very simple. This one, the next one, the extrusion, is much more interesting, I think, in the sense that it can create many possibilities for you, for your models. And for that, for extrusions, you need to create the curve first. So you need to have a profile curve that you will use to extrude upwards or direction that any direction that you want. So for this we used ellipse arc with the center, and ellipse arc is, you will see that this is the surface that we're talking about. It's the surface that just goes upwards to the direction that you want, but the ellipsis itself is this profile, this edge of the surface, and you can make it as big as you want, and also you can regulate like the minimum and maximum angles. So if you do like 45 on minimum, you will see that this angle, sort of it begins in a different way, but that's just forming the ellipsis. And if you have it from 0 to 365, then it will be a full ellipsis. That's how it works. It's sort of ellipsis cylinder then that is extruded, not exactly to the y direction, but a bit with x direction, and that what makes it, what gives it this angle of sort of pizza leaning tower. Yeah, so that's how it works, and this is the extrusion for you. Quite a simple thing as well. The next one is Revolve, the profile surface, which also needs curve as an input to be revolved, and it also needs the axis to revolve around, and then you also give the angle to revolve with. So we can also just put some color for that surface and see where it is. So you see it's there, and because it's angled 270, it doesn't go the all way. But let's just begin maybe with this Bezier curve that is the input, and Bezier curve just expects you to create the points and weights for those points. So you can look it up how Bezier curves work. But basically we create this edge, and then we tell the revolve surface that this edge needs to be rotated around the center of the surface in 270 degrees. And this is how it works. If you want to rotate around different axes, I wonder, maybe it should be possible. Let's try. Oh, yes, so that it didn't like that. But let's, for now, keep it on 0. I'm not exactly sure what went wrong there. But you get the point. I think it's quite self-explanatory, and you will recognize that this angle that you can put to 360, for example, that it will form the full closure of the revolved surface. So in this way you can model vases, columns, all kinds of nice things, and your profile can be any curve that you want as well. So be free to create polylines if you want to, or these kinds of NURBS curves. Another and last example is the sweep profile curve. That is a bit more complicated to create, but because it requires two curves as the input, so it requires the profile and the rail. And the profile, so this is the surface that we're talking about, and it required me to create the profile curve that is like this, and the rail curve that is like this edge. And then what the algorithm does, it just sweeps that profile curve along the rail. And you see then that for profile we use Bezier curve, and for the rail we use Bezier curve, and we create the sweep profile. And that's it. So, and then it is also moved away from the center. All those transformations you can just ignore, they are not really important, but other way, as you see here with that example, it would all overlap. So I hope you enjoyed this video. It's a short explanation of how those surfaces are created and what the idea is behind modeling in NURBS. Thanks for watching, guys. Please subscribe on YouTube, and see you in later videos. Bye.